All right, in the conclusion of chapter 15, we're going to be talking about 15.9, multiplication and division with complex numbers. So number one, question A, 1A, we're going to look at 4i times 1 minus 7i. And then that's all you're basically going to be doing is multiplying. So here we go. We're just going to multiply like we normally do. 4i times 1 is actually just 4i, as if you treated it as a letter x. And then 4i times negative 7, so or negative 7i. So you do 4 times negative 7, and you would get negative 28. And then I times I, which is I squared. Here's what we need to talk about. I, we learned in the last video, is equal to negative 1. Now, if I square both sides, notice what we learned earlier in chapter 15 too is a square and a square root would cancel out. So what I just learned is I squared is actually equal to negative 1. So I can rewrite this as 4i minus 28 times negative 1. Two negatives make a positive, so now I get positive 28. But our answers have to be in the form of a plus bi. So I have to switch these two and say 28 plus 4i as my final answer. So what we're going to kind of see new here is the I squared actually does equal a real number. So this is why we deal with complex numbers, is because two imaginary numbers multiplied together does produce a real number. All right, so let's look at another one. Let's look at 4 plus 2i times 3 plus 5i. And you can FOIL or box method this, doesn't matter to me. I'll do some box method since I've been doing a lot of foiling lately. So 4 and 2i, 3 and 5i. So 4 times 3 is 12. 4 times 5 is 20i. 3 times 2 is 6i. And 2i times 5i is 10i squared, which we now know is negative 10. So I'm going to scratch that out completely. But the I squared makes a negative. So basically what it does, it makes it become, it changes the sign of it. So if this would have been negative, it would become positive. And since it's positive, it is now negative. So when I combine like terms, 20i, or sorry, real numbers first. So 12 plus negative 10 gives me 2. And 20i plus 6i gives me 26i. All right, so get another one. We're going to look at the square root of 2 minus I times the square root of 2 plus I. We'll box method this. The square root of 2 times square root of 2 is just 2. We've learned that in this chapter as well. Square root of 2 times I, again, a lot of us write it as the I outside of the square root, but it doesn't matter. Negative 1 times square root of 2 is negative square root of 2, and negative 1 times I is negative I. So it's kind of all over the place here. Oh, I don't even know where the negative 1 came from. Hold on. I say the fact that it was all over the place was my first alert. Negative I. So this becomes negative I square root of 2, and then negative I times I gives me negative I squared, which we now know basically just changes the sign of the number. So this negative, there's an imaginary 1 there, now becomes a positive 1. So 2 plus 1 is 3, and then I squared root of 2 times negative I squared root of 2 cancel each other out, so 3 would be your answer. And that's pretty much all multiplication is there with complex numbers. So let's look at some division. So number 2, A, is 8 over 1 minus 2i. Since I is equal to the square root of negative 1, I cannot have a radical on the bottom. So just like before, I'm going to multiply by what we call the conjugate. And the conjugate, again, is going to be the exact same thing, but I'm going to change the sign in the middle. So instead of 1 minus 2i, I'm going to multiply by 1 plus 2i, both on the bottom and on the top. And then what you just saw too is when these guys are exactly the same, but different signs, I can just distribute the first and the last. So square root of 2 times square root of 2 is just 2, and negative I times positive I gave me negative I squared, which turned into a positive 1, which gave me 3. So I'm going to do the same thing here on the bottom. 1 times 1 is 1, and negative 2i times 2i gives me negative 4i squared, which we now know basically just changes the sign. So it's 1 plus 4, which is 5. Over here, I just got to distribute. So 8 times 1 is 8, and 8 times 2i is 16i. The issue with this answer is you have to write it in this form, a plus bi. So we have to split these fractions up. So my final answer will be 8/5 plus 16/5 I. Let's try another one. We have the square root of 5 minus 2i over the square root of 5 plus 2i. Again, my focus is the bottom here. I want to multiply by the square root of 5 minus 2i on both the top and the bottom. Square root of 5 times square root of 5 is 5. 2i times negative 2i is negative 4i squared, which we just learned that a I squared just changed the sign. So this is 5 plus 4, which is 9. Here, though, you can box method or fold it, however you want to do it. But square root of 5 times square root of 5 is 5. Square root of 5 times negative 2i is negative 2 square roots of 5i, or however you want to write it. And then negative 2i times square root of 5 is negative 2 square roots of 5i. And then negative 2i times negative 2i is plus 4i squared. So when I write this out, this is really 5 minus 4 square roots of 5i. And then we now know this basically just changes the sign, so it's minus 4. So 5 minus 4 actually gives me 1 minus 4 square roots of 5i. And then we have to split the fraction up. So this is 1/9 minus 4 square roots of 5 over 9i. All right, let's look at another one. We get 4 minus I over 4i. This situation, when you just have just a monomial, it's not a binomial, all I have to do is multiply by just I. Don't have to multiply by negative 4i or anything like that. If you just have a single term and not a binomial, I can just multiply by I. So 4i times I is 4i squared, which we now know just changes the sign, so it's negative 4. And then here I would just distribute. So 4 times I is 4i, and I times negative I is negative I squared, which we now changes the sign, so this becomes 4i plus 1. And then we have to change the order of this because it has to be a plus bi, so I'm going to have to write 1 plus 4i over negative 4, and then I have to split the fraction up. So this becomes negative 1/4 minus 4 over 4i. And then you do have to simplify this as well. 4 divided by 4 is 1, so that's negative 1/4 minus I, because I don't have to write the 1. So that's how you have to write this. So do simplify as you go on. All right, let's look at one more. Let's look at the square root of 3 plus 4i over negative square root of 3 plus 4i. So again, I'm going to multiply by negative square root of 3 minus 4i, so you just change the sign in the middle. We'll do the same to the top. And in this situation, again, negative square root of 3 times negative square root of 3 is just 3. And then 4i times negative 4i is negative 16i squared. We learned that the I squared changes the sign of it, so it becomes 3 plus 16, which gives me 19. Pull this out. Square root of 3 times negative square root of 3 is negative 3. The negative here, and then the fact that becomes square root of 3. And then square root of 3 times negative 4i would be negative 4 square root of 3i. 4i times negative square root of 3, again, would give me negative 4 square root of 3i. And then 4i times negative 4i is negative 16i squared. So this becomes negative 3 minus 8 square root of 3i. Changes the sign, so it becomes plus 16. But negative 3 plus 16 is 13 minus 8 square root of 3i. And then we separate those, so it becomes 13/19 minus 8 square root of 3 over 19i. That's about as complicated as it can get. All right, so I got one more question, and that will wrap up chapter 15. So let's look at number 3. You are asked to simplify each power. So you're going to be given something like this, I to the 37th. So here's what we need to see now. We have I equals the square root of negative 1. We just learned that I squared is equal to negative 1. What does I cubed give me? Well, I cubed would be the same thing as I times I squared. So that would just give me negative 1 times the square root of negative 1. So in this case, just negative square root of negative 1. Also known as negative I, because that's what that would be. Then I to the 4th is the same thing as I squared times I squared, which is the same thing as negative 1 times negative 1, which is just 1. And then we do I to the 5th, and we realize that this ends up being the same thing as I to the 4th times I. Well, I to the 4th is 1, and I is I, so therefore it's just I. So it starts over. So therefore, we don't need to know what I to the 5th is. These are the only 4 we need. So to wrap this up, you need to know that I is I, or square root of negative 1 if you want to write it. I squared is negative 1. I cubed is negative I. And I to the 4th is equal to 1. I'm going to go ahead and erase this part, though, because this would be the answer. So then I to the 5th is I to the 6th is negative 1, and so on and so on. So if you can see my pattern here, this would be 5, 6, 7, 8, 9, 10. And I could do this until 37, but I think one of the questions might even ask you, like, what is it to the 99th power? And you don't want to have to go there and count 99 times. So here is how I do this. If it goes into it evenly, so 4 times, right, the answer would be here. So if it goes into it evenly, my remainder would be 0. If it has a remainder of 1, then the answer is back to I. If it has a remainder of 2, then the answer is negative 1. If it has a remainder of 3, then it has negative I as the answer. And if it's no remainder, it would be 1. And what I mean by that is we're going to take whatever this exponent is, and we're going to divide that by 4. Well, 4 goes into 37 9 times with a remainder of 1. Right? So that 1 tells me then this answer is just I, without me having to do all that work and count. All right, so let's look at another one. Let's look at part B. Part B says I to the 14th. Right, so I'm going to take this 14, divide it by 4. 4 goes into 14 3 times for a remainder of 2. Remainder of 2 tells me the answer here is negative 1. And that's it. All right, let's do one more. So we got part C. We get I to the negative 8. So what happens here is I have to put this on the bottom. So I get 1 over I to the 8th. And then I go, all right, well, 8 divided by 4 is 2 even. So that means the answer is 1. So that becomes 1 over 1. But you have to simplify that. So 1 over 1 is 1. And that's it. That's all of chapter 15 and the rest of 15.9. So if you have questions, feel free to email me. Other than that, I will see you next time. Bye for now.